Everyone, I am Mahalakshmi, working as an assistant professor in physics in Hindustan College of Engineering and Technology. Today we are going to discuss a few topics under the unit wave optics. The topics like interference, diffraction, resolving power will be discussed. The objectives of this PPT is to demonstrate the phenomena like interference, types of interference, diffraction, types of diffraction, Raleigh's criterion, and resolving power. What do you mean by interference? Interference in physics is the net effect of combination of two or more wave trains moving on intersecting or coincident paths. The effect is that of the addition of the amplitudes of the individual waves at each point affected by more than one wave. Introduction. What happens when two waves meet? Two snooker balls would bounce off one another, but light behaves differently. They show behavior known as interference. There are two types of interference. One is constructive interference, the other one is destructive interference. What is constructive interference? Two waves on the left arrive in phase, that is in step. Resultant wave, that is the bottom left, has twice the amplitude. And what is destructive interference? Two waves on the right arrive out of phase with each other, and the result is they cancel out each other, and that is zero amplitude. Interference patterns. Constructive interference occurs the center point. The two wave trains travel the same distance. Therefore, they arrive in phase with each other and produce a bright area, that is a point P on the screen. And what do you mean by coherence? For interference pattern to occur, the phase difference at point on the screen must not change with time. This is possible only when the two sources are completely coherent. So the figure shows a section of infinite wave and a wave train of finite length. No independent sources can act as coherent sources because the emission of light by the atoms of one source is independent of that of the other. If the two sources are completely independent light source, the fringes appear on the screen. So the two sources are completely incoherent. Two types of interference as we discussed earlier, constructive interference and destructive interference. Constructive interference occurs when a crust meets a crust and when a trough meets a trough. Destructive interference occurs when the crust meets or superimposes with troughs. If a crest of one wave meets a trough of another wave, the magnitude of the displacement is equal to the difference in the individual magnitudes. This is known as destructive interference. Now let us see what is diffraction. Using Huygens principle to explain diffraction. Why do I hear people even when I am not in line of sight? So this is a question for thinking. That is, that concept is explained by diffraction. So when waves encounter obstacles, the bending of waves around the edges of an obstacle is called diffraction. Diffraction is classified into two types, Fresnel diffraction and Fraunhofer diffraction. Fresnel diffraction is produced by cylindrical wavefronts, whereas Fraunhofer diffraction is produced by planar wavefronts. And Fresnel diffraction, source of screen at finite distance from the obstacle, whereas in Fraunhofer diffraction, observation distance is infinite. In practice, often at focal point of the lens. And Fresnel diffraction move in a way that directly corresponds with any shift in the object, whereas this Fraunhofer diffraction is fixed in position. Fresnel diffraction patterns on flat surfaces, whereas Fraunhofer diffraction patterns on spherical surfaces. Fresnel diffraction change as we propagate from further downstream of the source of scattering, whereas Fraunhofer diffraction shape and intensity pattern stay constant. Let us see the next is the Rayleigh criterion. What is that? Rayleigh suggested by how much they should be separated in order for the two sources to be just resolved. If the central maximum of one diffraction pattern coincides with the first minima of the other diffraction pattern, then the two sources will be just resolved. This is known as Rayleigh's criterion. Rayleigh's criterion. If the two sources are sufficiently far apart, they can be seen as two separate diffraction spots, that is described in diagram A. If the two sources are too close together, the diffraction spots will overlap so much that they appear as a single spot, as in C. Two sources will be resolved as two distinct sources of light if their angular separation is greater than the angular spread of a single diffraction spot. This is shown in diagram B. This result is called Rayleigh criterion. For a circular opening, Rayleigh criterion for the angular resolution is theta minima equal to 1.22 into lambda divided by d. Two objects will be resolved when viewed through an opening of diameter capital D if the light rays from the two objects are separated by an angle at least as large as theta minimum. Rayleigh criterion is theta should be equal to 1.22 into lambda by b, where theta is the angle of resolution measured in radian, lambda is the wavelength in meter, and b is the diameter of circular opening in meter. This bigger the aperture, smaller the angles that is resolved. This figure shows the explanation for Rayleigh criterion, and figures 1, 2 and 3 shows that 3 and 4 shows the two sources, how they will be resolved or they will not be resolved. Let us see about microscopes. For a microscope, the actual distance when two points objects are just barely resolvable is known as resolving power. It's given by Rp equal to 1.22 into lambda divided by d, where d is the diameter of the aperture. As a general rule, we can say that it is impossible to resolve details of objects smaller than a wavelength of the radiation being used. Significance of resolution in the development of devices. CDs, that is compact discs, the information on the drive is read by lasers reflecting from the surface. A laser with a higher resolution can read more information from the surface of a disc. Electron microscope. Electrons are propagated with a very short wavelength through a species. Hence, the image produced is very clear due to the microscope's higher resolving power. Radio telescopes. The wavelength of radio waves is large, so the telescope needs to be large so that the resolution is good. Thank you.